Okay, so we're now going to look for lab 3. Can you find the classroom post for lab 3? And when you look at lab 3, you'll see that there are 2 links to that posting. One of those links is for a Google Sheet that looks like this. The other link, open that up as well, is for a simulation that we're going to use to collect our data that looks like this. Okay. Anyone need more time to get those 2 things open? All right, then let's look at the Google Sheet for a minute. When we look at this Google Sheet, make it a little bit bigger. There we are. You'll see that there are several tabs along the bottom. Let's go through the layout of this document that you're going to be completing. We start off with the directions tab. That's a great place to start, so we know what we're doing. Then, of course, we'll see that there are 3 experiment tabs, experiment 1, 2, and 3, where you're going to be inputting data that you've collected. And then we have an analysis tab, which we're not going to tackle today. That is our task on Monday, is to answer all of the questions on this tab, but we're not doing it now. Our task today is to collect data and make graphs for all the data. And it takes a little while to collect the data. That's why we're going to have a full class period to do that and make 3 graphs that go with the data. Let me start by going through the directions of this lab with you. And you'll see here on the directions tab that we're giving you a diagram of something that's called a simple pendulum. You see it says there that we have a simple pendulum. So let me define for you what a simple pendulum is. A simple pendulum is simply some mass attached to the bottom of a massless string that gets pulled back by a small angle and then is allowed to swing. Now, in real life, it is impossible to create a true simple pendulum. Let's talk about why. If you think about what I just said creates this pendulum, we have a mass attached to the bottom of a string that is massless. Is it possible to obtain a string that has no mass? No, it doesn't exist. And that's why this simple pendulum is a theoretical thing. It actually doesn't exist in real life. The simulation we're going to work with can model this for us, though. And that's how we're going to collect our data so we can look at what should happen if we had a string that had no mass. What we do when we pull it back by small angles means less than 15 degrees or less. If I pull it back more than that, this thing starts vibrating in all different directions, and it doesn't behave the way we want it to. What we expect it to do is when we pull it back a little bit, it then just swings back and forth, back and forth, and back and forth. What you will be doing in this lab, in each of the 3 experiment tabs, is building different simple pendulums that have different lengths, different masses, and you'll be pulling them back by different amounts. And your job is to not only build them in the simulation, but then time their swings. Now, let's just go over what a swing is, because if we don't all use the same terms, we're not going to get the correct data. When we talk about a swing, it means we pull it back by whatever angle we're telling you to pull it back by, and then we release it so it goes out and back. Out and back is considered to be one swing. Not out and back is one. When we do this lab, you are not going to time one swing. I'm going to ask you to time 10 of them. Out, back, 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 10 times in one shot. And the reason we time 10 of them instead of one is because we all have what's called a reaction time. Do you know what I mean by a reaction time? There's a delay between by the time you see something and the time you can do something. It's based upon how long it takes the electrical signals to go from your eyes to your brain and then down to your fingertips. Or if you're driving a car, from what you see to what your brain interprets to then to your foot to go from the gas to the brake pedal. Our reaction times are pretty quick, but they turn out to be fairly significant when you're looking at the time of just one swing. If we do 10 swings, we can spread out that reaction time error over the 10 swings, and it's not significant anymore. So it gives us better data. We would get even better data if I said don't time 10 swings, but time 30 swings. Or time 100 swings would be even better. But then we have to make sure, it just takes up too much time to do that. So we're only going to time 10 swings. Now let's look at the simulation, and I'm going to show you how to set up the simulation to collect your data. So when we look at this simulation, I would like you to go ahead and click on that intro tab. And you'll see that on this simulation, we have several things that are here. I'm going to help you get it set up for the first set of data that we want to collect. On the bottom left, we have a series of checkboxes. Please uncheck the ruler and check the stopwatch. So this is the stopwatch we're going to use in the lab to collect our data. We're going to hit the start and the stop button, just like that. Start, stop, and then this reverse arrow resets it. Everybody okay with that? You have that up on your screen? Good. Okay, on the top right is where we can adjust the parameters of the length of the pendulum and the mass. If I go to the lab that you're doing and we look at experiment 1, you'll see that data table 1 gives you the parameters here in row 3 for the first pendulum you are going to construct. It needs to have a mass of 0.1 kilograms, be released by a 9-degree angle, and then have a length of 0.60 meters. So if we go into the simulation, we can adjust our mass down to 0.1 kilograms like it asked for. We can adjust the length. The length again was 0.60 meters. So back to this. Let me adjust that down to 0.60 meters. There it is. And then to create the angle that I'm looking for, I just click on the mass. As soon as I click on the mass and I'm holding down my mouse key, I can see on the top of the window, I get the angle. You see it? It shows me right now it's 0 degrees. I'm then going to pull it to the right until I get to that 9-degree angle that I want. Once I have it at the angle I want, I just release it, let go of your mouse, and it will just start swinging indefinitely. Let's do this first one together, okay? What I'm going to do when I start timing it is I'm going to time it from the moment it reaches this end here on the right, and then I'm going to count to 10 out and back, and then I'll stop it when it reaches here again. Okay, this one's going pretty good. Earlier today, the Bluetooth was choppy, and so kids couldn't see it. I'm going to let that go through the break. When we come back from the break, I'll show you how to time that. Okay, take your break. And when you come back, we'll collect our first set of data. I'm sorry? Did you pull it back? You got to pull it back to 9 degrees. The number to be 9. So you got to go the other side. And then release it. Are you on the There you go. Yeah, just don't hit this button. Okay? Don't hit the pause button. We'll just keep going. Yep.
So for this one, you say that.
Which one?
This one.
Yep.
X, this must be positive.
No. Nope. So you're going to have a minus sign in that. You move the negative sign over with the K.
What about this?
That you just leave it like that. We don't have to worry about the plus or minus outside the red. We're going to learn later what that negative sign means. Okay.
Thank you.
You're welcome.
No, we're not. Because the direction says which is exactly right. We didn't do that, or we didn't give answers to questions.
Well, that's what we did last
To watch the video. By which. So. Right? I gotta come up with the correct answers before. I'm gonna give this back to you. You're not gonna correct anything on this. And then when you have the time, just keep it safe. You're welcome. And then you'll get half your points.
It's not making any difference. All right, ladies and gentlemen, let's now talk about how we're going to get this data. All right, so my pendulum is swinging. Is yours? Okay, just let it keep swinging. Let it keep swinging. Notice it really doesn't matter that it's swinging. It's going to keep going forever. Because this is a simulation. It will keep going forever. In the real world, it wouldn't, because there'd be some friction involved with the swing, which would eventually cause it to stop. So because this is an ideal situation, I don't have to worry about that. I can let it swing forever. And what I need to do when I time it is start timing it when it reaches either of these high points. I'm always going to time it from when it reaches here. Watch me do this on the screen first, okay? And then I'll have you try it to make sure you get an answer similar to mine. So I'm waiting for that to reach the high point on the right. And then when it does, I'm immediately going to click the play button on my stopwatch. Ready? And go. So there I'm counting 1, 2, 3, 4, 5, 6, 7, 8, 9, and stop. So there is my time, 15.52 seconds. What I then will do, and you can take this time yourself, is go ahead back into the Google Sheet for experiment 1. That was the pendulum I just constructed and timed. The time for 10 swings is the only cell I'm going to type into in yellow. And I put 15.52, and that's it. I do not put the units after it. You follow how I just did that one? Okay. I'm not going to do any more of these. You're going to do all the rest. That is, I need you to complete all of the data in table 1.1. I need you to get all of the data in table 2.1. And then all of the data here in table 3.1. And that's it. Don't do anything more. Do not edit any other cells in that Google Sheet. There are formulas behind this to make it do some calculations behind the scenes for you. All right, so please go ahead and collect that data. If you want to partner up and share with the person sitting next to you at your lab table, so you're doing one experiment, they're doing another to speed it up, you certainly can do that, okay? Otherwise, I'll give you time to get all of the data yourself. When you do get all of the data, you can close the simulation. We won't be needing that after the you get all your data today. Are you going to get the same times as the person next to you? No. You have different reaction times, but they should be pretty close, and that's all right. And we got to get all 3 experiments, just the data collected. No, you got to get all 3 experiments. As I just said, you got to collect data for all 3 tabs, and then you're done for now. I just need everybody to get all 3 experiment data collected. Don't make any graphs. All you're typing in is the shaded cells in the first data table on each tab.
I'm sorry. No, that's what we're gonna find out. So we do this. Let's get the numbers in there. And then we'll analyze the numbers later. Some may change, some may not. We're going through all 3 experiments. Remember, you can share your data with the person next to you, so that way you're only collecting data for 1.5 experiments instead of 3. She didn't have to approve it. That's the yeah, she's showing me that. So yes, should be. Yeah. Upstairs.
Give you a couple more minutes to get all that data, and then we'll work on making the graphs together because they're different. They are not our usual graphs that we see. Excel likes to be a little picky with these ones. Can I just see a show of hands? Who is still collecting data? Okay. All right. Who's still collecting now? Okay. You're not sharing data with your partner next to you. That was your other option. You didn't have to do all of it. You just had to do a table and a half. And I said, then get the other half from your person sitting next to you. Split it up. Okay. Let's go over how to make the graphs. We're going to do these together, okay? So let's start with experiment number 1, please. I'm going to turn off the light so you can see this a little bit better. I think we still have enough light in the room to see what you're doing. Yes? Yes? Okay. So what I'd like you all to do is put your cursor in cell A10. You're in experiment 1. Put your cursor in cell A10. Then hold down your shift key, right arrow over, and then down arrow until you get to cell B15. So now in your name box here, it should say A10 colon B15. That is the data that the Google Sheet computed for the periods, which is the time for one swing. It did a calculation, as I told you, behind the sheet to give you the period, the time for one swing, which is what we're going to create a graph of. Notice that it calculated them here and it's just copying them over here so that way we can make a graph of the period versus the mass. I would now like you to go to your insert menu and go to chart. This is not the correct graph for what we need. So we have to make a lot of modifications to this graph. So please do them with me. I'll do the first one and then I'll turn you loose for the next. So please go in your chart editor window to the customize option and select chart and axis titles. The title is incorrect. And why is it incorrect? Because it included units in the title. So first thing I'd like you to do is delete those units from this title. So the title is just period versus mass. Okay. All right, collapse that menu because we can see that now our vertical axis is labeled period in seconds. The horizontal axis is labeled mass in kilograms. That's good. The next thing we're going to look at is the bottom left corner of our grid. Notice that this graph does not start at 0 on the horizontal axis, and it needs to. To make that happen, you have to force that by setting the horizontal axis minimum value. We do that here under the horizontal axis submenu. And now what we're going to do is come down and set the minimum value to 0. Remember, we learned how to do that the other day. Set the minimum value on the horizontal axis to 0. And now you can see you have a 0, 0 on the bottom left, which is what you want. And you have the vertical axis grid line there, which we need. Now you can collapse that submenu. Now we're going to add our best fit line or curve. And when I look at this, if I were to try to connect these dots, they would pretty much go straight across. That means I'm looking for a trend line, which is a line, a horizontal line pretty much. So go to your series option. We're going to select trend line again. It is linear. That is the best fit for that graph. And then we have to add the equation to this graph by changing the label to use equation. That graph is now done, but it's not where it needs to be on this tab of our Google Sheet. Click on your graph, and I want you to drag it down on the page. You'll see that I've given you a yellow box for the graph for experiment 1. Please drag that graph into that yellow space so it's not covering anything else up. You'll see that when I make my window a little bit bigger, you can see that the graph is fitting right in that box right there. It's not outside of that. Everybody all set with that graph with me? Anyone need more time to fix that first graph? Okay. I want you to try to make the graph for the experiment 2 using the data table 2.2, this data right here. Okay, go ahead and make that graph. And then after you've made that one, we'll check it together. So I'll freeze my screen while you're making that one. Anyone need more time to make the graph for experiment 2? All right, let's check it then. When we check your graph, did you fix the title? So it says period versus angle of release. You got rid of the units. Did you fix the horizontal axis so that way it starts at 0? If you didn't, fix it now. Did you add a linear trend line and add the equation for that linear trend line to the graph? Did you move it down into that yellow space where it says graph for experiment 2? Okay, so your graph looks like mine, just maybe a slightly different equation because it's based on the data that you collected, not my data. All right, so now let's go to experiment 3. I'd like you to try this one on your own as well for experiment 3 using the data in table 3.2. Anyone need more time for this graph? Okay, let's check it. This one was a little different. Your title should have been adjusted to read period versus length of string. You got rid of the units. Did you add the 0 on the horizontal axis? Now the trend line, this one was not linear. Linear didn't fit the data points perfectly. If you tried the other type, what's the other type of trend line we can use? Power series. If you try that, now all the data points go right on the best fit curve. Add the equation for that on there. Make sure it's in the yellow box, and then you're done. All right? Any questions on this one? Remember, when you're trying to decide whether it's a linear or power series trend line, try them both. Go back and forth between. Whichever one fits the data points better is your best fit. This case is definitely the power series, not the linear. Any questions? Okay, you are not going to do anything more with this lab. You're going to close it out, save it. On Monday, we'll be doing the entire analysis tab to complete this lab and turn it in before you leave on Monday. Your only task now is to work on the review. And if the review packet is done, then you can work on something quietly for another class. But that's it. We're not completing this lab today. So do not turn it in.
Good.